Hey guys, it's 11.5, solving exponential equations with logarithms. Our objective is that we will solve exponential function using log. So in our previous lessons, we talked about method of common bases, making everything have the same base, and then we go ahead and solve it. Now today we're going to use a more general method and our calculators, of course, and our last logarithm law, which is the power law. This is our power law. You should remember this from previous lessons. So the first one says, how do we solve 4 to the x power is equal to 8? And I want to solve this using the common bases, and I also want to solve this using the logarithm law. So the common basis is making these have the same base. So I look at 2 and 4 and 8, and I know I can make them in 2's. So for example, 2 squared, that will give me 4, keep my exponent outside. And then I have 2 to the third. This is actually 2x is equal to 3. They have the same base, and then this is my distributive property. If I go ahead and solve this, I get x is equal to 3 over 2, or 1.5. Now, if I do this in the logarithm approach, it's the same exact thing. So if you look up here, remember my power law, I kind of went backwards. So now I want to write this. Somehow it will look like this. So the first thing, this here, if I transfer this using my logarithm law, our power law, I would get the log of 4 to the x power is equal to 8. And then using this, this should be the log of 8. Using the power rule, we take our exponents, bring it forward, so we have the log of 4 is equal to the log of 8. And solve for x. This is all what we have been doing. Divide both sides by the log of 4. Put that in your calculator and we'll get the same exact thing, which is 1.5. So to translate this as the log of this piece has to equal to the log of what it is. Now, the beauty of this log is that it removes the variable from the exponent, and this law, it will help us in base 10, which is the common log. If you put it in a calculator, you don't write a base. Remember I told you it's the common log, which is always in the base 10. So here, solve each of the following equation for x and round it to the nearest hundred. So this means 2 decimal places. Now let's get some space here. I'm going to do the first one, and you're going to do the rest. So this, again, how do we write this? The log of 5 to the x is equal to the log of 18. Power law, bring that forward, and I have everything else. Then solve for x. The log of 18 over the log of 5, which is approximately 1.80. And how did I get that? Just plug that into your calculator. So go ahead, pause the video, try B and C for me. If you had a chance to try B and C, you should have gotten 3.32 and 10.61. Now what we're going to do, it says these equations can be a little more complicated. As you know in math, everything gets a little more complicated. And every time you use the logarithm law to transfer the exponential equation into one that's very familiar. So don't get scared. You can do this. I am 110% sure that you all can get this done. So let's see what's happening here. Let's do the same exact thing. The log of 6 x to the third is equal to the log of 50. Use my power rule, so this is x to the third. The log of 6 is equal to the log of 50. X to the third is equal, remember this is multiplication, so I'm going to divide both sides. The log of 50 over the log of 6. But now be careful because I don't have x by itself. I have x plus 3. I want this to be x by itself. So I will have to minus 3 on both sides. So this is the log of 50 minus the log of 6 minus 3. And if you put that entirely in the calculator and make sure the minus 3 is outside of this fraction, you should get it's approximately, how much, where am I running this? Hundredths. It's approximately 0.82 as my final answer. Alright, see, it was very similar to what we just did. There's just one more step now. Instead of having x, I have x plus 3. So let's see what's happening on this side. So we'll do our first step. The log of 1.03 x to the second minus 5 is equal to the log of 2. Bring everything in the front times log of 1.03 is equal to the log of 2. X over 2 minus 5 is equal to the log of 2. Divide both sides by the log of 1.03. But now, this is what we've been doing up here on these examples. But now, I want to do one more step. How do I get x by itself? So the first thing I would have to do is add 5 on both sides. So I'm left with x over 2 is equal to the log of 2 over the log of 1.03 plus 5. Now this here, I still am not done. Oh man. I need to get rid of this 2. It's dividing, so the inverse of this is multiplying. So now x would be 2 times this entire thing that I have here. I have to multiply my entire answer. Because remember, if I times this by 2, that's cancel and I'm left with x, and then I will have to do that on this side. And I put this in the calculator and I round it, I'll get exactly, approximately actually 56.90. Alright, I know that was a little, just take a minute, pause the video if you get frustrated, and think about what's happening here. So moving on. Now we're familiar with this method, we can relook at exponential models. So if the quantity is increased, remember we talked about this, it's always whatever q of t is equal to q of o, 1 plus p to the t. So q of o represents the amount, t is the time. So this looks just like something like exponential growth. So it says, a biologist is modeling the population of bats in a tropical island. When he first started observing them, they were 104. He believed that they grow at a rate of 3% per year. Write an equation. So this is just like we used to write. It can be b of t, that's what they tell us. My starting is 104, 1 plus 0.03 raised to the t, which is the same thing as 104. Either one works. This is like an exponential growth. Now it says, using this equation, algebraically determine the number of years it would take the bat to reach 200. Run your answer to the nearest year. So I know it's 104, 1.03 to the t has to equal to 200. Now this is just like what we did. How do we make this into log? So first of all, let's just get rid of this 104. So I have 1.03 to the t power, which is actually 200 to the 104. This looks like something that we worked with on here. When I have something raised to something power is equal to something else. So because I need some space, I'm going to take this out and I'm going to write on this side. So I'm going to just draw an arrow. Now, how do I do this? Remember, this becomes the log of 1.03 t is equal to the log of 200 over 104. Using the power rule, I have t log of 1.03 is equal to the log of 200 over 104. Get t by itself, which is the time, what I'm looking for, 104. I remember this is multiplying here, so I'll do the inverse, which is the log of 1.03. And if I work that out in the calculator, what am I going to get? I will round this, so it will be approximately 22 years, which is what they asked me to round it to the nearest, oops, not to cross that out, to the nearest year. Okay? Now, exercise 5 says, a stock has been declining in price at 5% per week. Declining, so that's like an exponential decay. If the stock started at 22.50, determine algebraically, the number of weeks it'll take for the price to reach 10 bucks. So let's write our equation first thing. It starts at 22.50 and it's declining at 5% per some time. I want to know when is it going to reach 10 bucks. So if I solve this out, it's 2250.95t is equal to 10. Get this in the form of something that I want it to be, where I can do my log and my laws. 10 over 2250. And now this from here, I should know what to do. So from here, just like what we were doing, the log of 0.95t is equal to the log of this whole thing here, 2250. Using the power law, remember multiplication there, is equal to the log of 10 over 2250. Get t by itself. You have the log of 10 over 2250 divided by the log of 0.95. And if I round this up, it says round your answer to the nearest week. So that means the nearest whole number will be approximately 16 weeks. Okay? And what did I do? Just put this in the calculator. Now the last question says, consider the expression the log of base 5 of 70. Write an equivalent exponential. Remember my little trick that I showed you guys? Remember my trick as the log of 100 in base 10 is equal to 2. To translate that to an expression is always the base to the exponent, bam. So knowing this, I would write 5x, oh, that doesn't look like a 5. I would write 5x is equal to 70. And that's my this and this here, they're equivalent to each other. It says solve now this equation. So remember, this will be the log of 5x equals the log of 70. Power rule. Get x by itself. Log of 70 over the log of 5, which, and what am I rounded? Nearest hundredths, which is 2 decimal places, 2.64. Alrighty guys, that's it for this unit. It's all about using that power rule for logs. Go ahead, try those practice problems. Good luck.